Now let us try to understand why the meter data management system is required. So as we know that the large volume of data received from smart meters need to be processed. So for that the meter data management system application is required. The data may be faulty at times. That means we need validation and cleansing. Metadata is fed into other critical systems such as customer relationship management system, billing, asset management or reporting. So for carrying out these activities, we need metadata management system. It also handles the crucial information as it needs to revenue generation. The MDM can be used to analyze trends in resource usage based on parameters. Analysis report can be used for providing enhanced customer experience. Say for example, the analytics are built in the metadata management system. So if you want to show customer the consumption pattern and the future trend of the energy usage, the customer will have enhanced experience because now he can see what is his consumption pattern, and if it is going beyond a particular limit he can reduce his consumption for the future billing saving. It can also do the trend analysis, which can be used to handle the cases of missing revenue or the revenue leakage. So the analytics which we develop in the metadata management system, these analytics are capable to process the data for specific business purpose. Say if you want to understand where is the revenue leakage or where the revenue is missing. Also, as we discussed previously, we can do the customer segmentation. We can check the consumption pattern of the individual customers, and we can find out if there is a suspected customer who is changing his consumption pattern frequently, and we can segment that customer as a suspected customer, and we can further check whether there is some energy theft case. So those kind of trend analysis can be done effectively with the help of metadata management system. So it can also be used for potential growth of the utility, like it can suggest what will be the load growth in future, and accordingly the utility can take action. So metadata management system is a biggest enabler for smart analytics related to consumer data. So lot of analytics can be built based on certain business or the technical cases, so that the adequate action can be taken by the utility. Now let's talk about the certain standards for smart meter. So first is IS 16444. So IS 16444 was adopted by Bureau of Indian Standard in 2015, and it consists of two parts. First part is IS 16444 part 1, which was released in 2015. It is also called as standard for whole current meter. That means these are specifically designed for low power consumption loads. So this contains static watt hour direct connected meters consisting of measuring elements, time of use registers, display, load switch, and built-in or plug-in type of bidirectional communication module, all integral with the meter housing. It is a smart meter for indoor use and capable of forward, that is import, or both, that means import as well as export energy measurements. It covers the general requirements and tests for AC static direct connected watt hour meter having accuracy of class 1 and 2. Now let's talk about the second part of the standard, that is IS 16444 part 2, that was released in 2017. In this standard, the smart meters are transformer operated static watt hour meters or var hour meters consisting of measuring elements, time of use register, display and built-in plug-in type of bidirectional communication module, all integral with meter housing. So these are transformer operated, means CT operated, generally used for huge load because you need CT for converting the high current to low current for measurement purpose. So that's why these are called LTCT meters or CT operated meters. These smart meters are again for indoor use and capable of forward, that means import, or the reverse as well as forward, that means import as well as export of the energy measurement. It covers the general requirements and tests for AC static transformer operated watt hour and var hour meters having the accuracy class of 0.2s, 0.5s and 1s. So 0.2s means the accuracy is high for even low measurement quantity. So for that you need 0.2s, which ensures that you will get this level of accuracy even the measurement quantity is very less when you compare with the overall measurement span. Let's talk about the IEC standard. So IEC 62056, commonly known as DLMS COSEM protocol. So it is the set of protocols for electricity metering data exchange, which was suggested by IEC Technical Committee 13 Work Group 14. Now it is an international version of DLMS, that is Device Language Message Specification, and COSEM, that is companion specification for energy metering. So COSEM consists of the set of specifications that define the transport and the application layer of DLMS protocol. DLMS Users Association defines protocol into a set of 4 specification documents. So Green Book document provides the DLMS COSEM architecture and protocols. Blue Book contains COSEM interface classes and OBIS, that is Object Identification System. Yellow Book contains DLMS COSEM conformance testing processes, and White Book is mainly for glossary of terms. So these 4 set of documents are part of the DLMS protocol. So it is not only applicable to electricity metering, it is equally applicable to water, gas and heating metering system also. Now here all the data in electronic meters and associated devices are represented by means of mapping them to appropriate classes and the attributes. So whatever the data you capture from the sensors in the smart meter, those are mapped appropriately to various classes and their corresponding attributes. It specifies an interface model and communication protocols for data exchange with metering equipment. Now let's see the specification approach DLMS COSEM follows. So here the DLMS COSEM specification follows 3-step approach. First step is the modeling, means it covers the interface model for metering equipment and rules for data identification. That means various interface objects which are required for data binding. So the data will be mapped to various classes and then to the various corresponding objects as per DLMS User Association documents, which are defined in Green Book and Blue Book. So modeling is required so that the data can be properly mapped to corresponding methods and the objects. Now next is messaging, that means it covers the services for mapping the interface model to application layer protocol data units and the encoding of APDUs. Now, what messaging does? It basically gives you the structure of various methods where you can just invoke that method to get the required information. Say in this case it is service ID, where you have various attributes to be sent to get the service ID. So now this is the message which is in the high level language. Corresponding APDU, that is the application layer protocol data unit, will be in hex format, and this hex information will be shared through the network to the remote server. So this messaging is important because this information has to be structured in a standard way so that the APDU which is developed out of this message can be recognized by the receiving end servers or the devices. So third part is the transport. That means it covers the transportation of message through various communication channels. Let's talk about the DLMS COSM communication model. So here the DLMS COSM communication model follows the client server model, where the smart meter acts as a server and the applications which are installed at the server end are acting as a client. So this client server model uses the concept of OSI model to model the information exchange between meters and data collection system. So data collection systems are nothing but applications which are responsible to receive the data sent by smart meters. Now, application functions of meters and data collection systems are modeled by application processes. So, at various end you will see various application processes, and the communication between application processes is modeled by communication between application entities. So, application entities represent the communication functions of application process. So, if you see in this figure, this is the DLMS COSM server system. So this is part of your smart meter where you see various application processes initiated by various logical devices. Logical devices are nothing but the virtual component of the physical devices. So here it can be like voltage measurement or maybe the current measurement, which are nothing but the virtual part of your voltage and current sensor. So they provide the data sensed from the power lines. So you will have multiple logical devices built in the server. These application devices will have separate application processes for sending up data. So these application processes are responsible to send data to the client side application process. So now these application processes will send data to the transport layer. How they will interact with the transport layer? They will interact with the transport layer through service access point, and they will send data to the layer where the information is further sent to the other layers like intermediate layers or MAC layer or physical layer, and then from physical layer it is converted into signals which are communicated over the network to the client, and then at the client level again the data is processed from physical to MAC layer and then the TCP UDP layer or maybe the SDLC layer. So these SDLC and TCP related models we will discuss in the next few slides. And then again the client application process will receive data through service access point of the transport layer. This will be the physical software application which will generate the service request, and then DLMS COSM application layer will convert that into the APDUs, and then this information is shared. The same will happen here also. So various application processes will generate the data, and that will be converted into APDUs, and this information is flown from this site to the other sites.